This study serves as a comprehensive guide for learners interested in understanding how to effectively apply ARIMA models to time series data, particularly in the context of monthly sales figures. What is an ARIMA model? An ARIMA model is a popular statistical method used for analyzing and forecasting time series data. It combines three key components. Autoregressive, this part of the model uses the relationship between an observation and a number of lagged observations. Integrated, this component involves differencing the data to make it stationary, meaning that the mean and variance are constant over time. Moving average, this aspect of the model incorporates the dependency between an observation and a residual error from a moving average model applied to lagged observations. For a more detailed understanding of ARIMA models, you can refer to the time series analysis and its applications by Robert H. Shumway and David S. Stauffer. Steps to fit an ARIMA model. Fitting an ARIMA model to the monthly sales data involves several systematic steps. Step 1. Visualize the data. Before fitting an ARIMA model, it is essential to visualize the data to identify trends, seasonality, and potential outliers. Tools like Python's matplotlib or R's ggplot2 can be used for this purpose. Step 2. Check for stationarity. A stationary time series has constant mean and variance over time, which is a prerequisite for fitting an ARIMA model. You can use the augmented Dickey-Fuller test to check for stationarity. If the p-value is greater than 0.05, the series is non-stationary, and you may need to differentiate the data. Step 3. Differencing the data. If the data is non-stationary, you can differentiate it to stabilize the mean. For example, you can use the following code to difference the series. Step 4. Identify ARIMA parameters. The next step involves determining the parameters P, D, and Q for the ARIMA model. You can use the autocorrelation function and partial autocorrelation function plots to help identify the values of P and Q. Step 5. Fit the ARIMA model. Once you have determined the parameters, you can fit the ARIMA model using the stats models library in Python. Step 6. Evaluate the model. After fitting the model, it's crucial to evaluate its performance. You can assess the residuals and use metrics such as AIC and BIC to determine the model's goodness of fit. Step 7. Forecasting future sales. Finally, you can use the fitted model to make forecasts about future monthly sales. Worked out example. Let's consider a hypothetical monthly sales dataset for a retail store. Following the steps outlined above, you would visualize the data, check for stationarity, apply differencing if necessary, identify the AR and MA terms, and fit the ARIMA model. For instance, if you determined that P equals 1, D equals 1, and Q equals 1, your model would be ARIMA. In conclusion, fitting an ARIMA model to the monthly sales data is a powerful technique for time series forecasting. By following the steps outlined in this article, learners can gain a solid understanding of how to analyze and predict sales trends effectively. For further reading, consider exploring resources such as Forecasting, Principles and Practice by Rob J. Hinman and George Athanasopoulos.